Okay, so this one is a distance versus time graph. You got distance on the y-axis, time on the x-axis. All right, what does the slope represent here? Well, your slope is y values over x values, right? What are your y values? What are your y values? Distance. And what are your x values? Time. And when you say distance divided by time, what do you come up with? Yeah, that calculates speed or what? Or velocity. Okay, so the slope on a distance versus time graph gives you speed or velocity. You guys got that? All right. So the slope is speed or velocity. Smiley face because it's Friday before a holiday. All right, now, on this particular graph, is the slope the same the whole time? No. Okay, guys, on a distance versus time graph, everybody look. If the line on a distance versus time graph is perfectly horizontal, that would be zero slope, right? Which means the object is not moving. If it was vertical, we can't do that. That's like super light speed, right? Okay. But no motion at all, impossibly fast motion would be vertical, right? So the steeper the line, what? The faster. Okay, so horizontal, no speed at all. As the slope increases, it's telling you that the speed is increasing. Does that make sense to you guys? Okay, so if you look at this graph, what can you tell me about the slope at first, down here? Is it big slope or small slope? Small, which means that the velocity is small or slow, right? Okay, but here the slope is steeper, which means the velocity is faster or higher, okay? All right, so let's describe the motion. We're not gonna bother calculating specific parts of this. So at first, the slope is almost horizontal. Horizontal. Okay, and that means a slow speed, right? And I'm going to run out of room, but we'll just squeeze it in somewhere. But slope, oh, where am I going to go? No more room. Okay, everybody follow me. Okay, but slope does what? Increases. Meaning the object gets faster. Okay. So, yes, sir. Can I help you?
It's okay.
All right. Is everybody good? Did you follow my little choose your own adventure? Because I ran out of room. Okay. So on that graph, the slope is getting steeper and steeper, which means the object is speeding up. It's getting faster and faster. If the object is speeding up, we can also say that the object is Accelerating, yeah. So a curved line on a distance versus time graph would indicate something accelerating, because as time goes by, the slope gets steeper and steeper. Okay, let's go to the next graph, which is down here. What type of graph is it? Yeah, it's another distance versus time graph. Okay, so what does the slope on this graph tell you? Yeah, good. Because it's, again, it's y values are distance, x values are time, so your slope is going to be speed or velocity. Okay? All right. Y'all know from math class that slope is just like y2 minus y1 over x2 minus x1, right? Basically, that's a fancy way of saying change in y values divided by change in x values. Okay? So let's use this point right here, and we can use 0, 0 as our other point because that's easy. How much does the y value change? By 20. All right? And okay, and then the x values start at 0, end at 10, so that's a change of 10. What's 20 divided by 10? 10. What? 20 divided by 10 is not 10. 2. Okay. All right. And it's y units over x units, so it's meters per second. Does the slope of this line change at all? No. Does the slope of the line change? Does the slope of the line change? No. It's a straight line, which means that this object is going 2 meters per second the whole time. Does that make sense? So this object is moving at a constant velocity of 2 meters per second. Everybody got it? Okay, so here's what we're saying. The object's moving at a constant velocity of 2 meters per second. It is not speeding up. It is not slowing down. There is no acceleration. How do I know? Because the slope of the line remains the same the whole time. Do you understand that? Now, here's a big thing that I want you to understand. Look at the two bottom graphs. Do they look similar? They look similar. But this one is a distance versus time graph. What's this one? That's a velocity versus time graph. Okay? A straight line on a distance versus time graph means something is moving with constant velocity. A straight line on a velocity versus time graph means something completely different. It means acceleration. You have to pay attention to whether it's a distance versus time or a velocity versus time. Okay? Because these two guys look the same, but because your y-axis is not the same, the meanings are completely different. Do you guys see that? Yeah? Sure, Miss Goff. Okay, that sounds great.